So first of all, why do we need streaming analytics? Here are some numbers coming out of a study from Akamai, which states that viewers start abandoned streams that take more than 2 seconds to start up. And 1% of rebuffering causes people to watch 5% less of a video. Viewers who experience video failure are less likely to revisit a web page. And 40% of customers are unlikely to give a streaming service a chance on a second device after being confronted with an inferior stream. And of course, in order to get these numbers, we need a streaming analytics solution which is measuring these kind of metrics. Next up, we are looking at streaming analytics solutions currently in use by content providers. And these are some numbers borrowed from the 2020 Bitmovin Video Developer Report, which states that over 50% of content providers are simply using Google Analytics for measuring purposes. And also notable that 17% are not using any streaming analytics solutions at all, or are measuring it some other way, not being covered by one of the commercial solutions. But streaming analytics are becoming more important as streaming architecture has become more robust over the last few years. It is now the time to understand what is happening in front of customers, measure their quality of service and quality of experience. And as part of that, it's also important to look at streaming analytics standards, such as SANS CMCD CTA 2066, which I will explain in the next few slides. Of course, the goal of using standards in this area is to improve interoperability, compare metrics across different solutions better, and basically use a common language to describe metrics, events, aggregated metrics, and so on. So the first standard in the streaming analytics area that I will cover is called SANS, and it stands for Server and Network Assisted Dash. It is standardized and published as an ISO MPEG standard, and it introduces bidirectional messages between Dash clients and network elements, or between various network elements, for the purpose to improve efficiency of streaming sessions. As you can see from this description, SANS not only covers player to server metrics, but is basically a standard to enable many more use cases, such as server control over players, something called the shared resource allocation feature, where the server assigns a certain bitrate to a Dash player. Also by having components which are called Dash-aware network elements, you could implement use cases such as real-time multi-CDN switching by having servers which are aware of the Dash streaming format and steer clients accordingly. There are many more use cases possible with SANS, which are described in the Dash-IF white paper, which is linked in this presentation. But what we want to focus on in terms of SANS is its metric reporting feature, which is using metrics which are standardized in the MPEG Dash standards as part of its NXD. And it covers metrics such as TCP list, HTTP list, rep switch list, buffer level, playlist, and device information list. These are metrics that are collected from a Dash player and are then sent via HTTP post or WebSockets to the metric server. Next up, we are taking a closer look at the SAND architecture and how we implemented the metric reporting feature. We call this implementation the SAND library, which provides an adapter for each Dash and HLS player. I'm explicitly mentioning HLS here, even though the SAND standard officially only supports Dash players. We made some adaptations in order to support any player, and we do this by attaching the adapter of the SAND library to each player's API, which is receiving the raw metrics from each player. We wrap this in an XML or JSON and send this to the so-called SAND server, or in terms of SAND, it would be the metric server, which is receiving these metrics and persisting them in a database. As part of the architecture diagram, you can also see the shared resource allocation messages. As mentioned before, this is a way for the server to assign certain bit rates to a player. So as part of that, you can see that the SAND library would send a so-called shared resource allocation message to the server, signaling that it is willing and able to receive shared resource allocation assignments, and the server is sending back such an assignment. Usually this would be a bit rate that then needs to be enforced on the player side via the SAND library. The next standard I'm covering is called CMCD, which is short for Common Media Client Data. It was just recently published in September 2020, coming out of the CTA Wave group. Its goal is for media player clients to convey information to content delivery networks with each object request. For CDN providers, this is useful for log analysis, quality of service monitoring, and delivery optimizations. And of course, overall, the goal is to improve the quality of service offered by content delivery networks. The transport of CMCD metrics is done via custom HTTP request headers or via HTTP query arguments. So basically you are attaching query parameters to each manifest, segment request, or even license request. Or it is also possible to send JSON objects which are independent of the HTTP object request, which makes this transport method very similar to how SAND metric reporting works. If you're interested, there's a more detailed explanation of how this CMCD support was integrated into Dash.js as part of a blog post. And also worth noting is there are efforts in the CTA Wave group to standardize the server part of CMCD, which will be called Common Media Server Data, CMSD, which could potentially also enable use cases where servers are using the back channel to send certain information to the clients and players. Last but not least, I'm introducing the third standard, which is called CTA 2066. It specifies a set of media player events, properties, quality of experience metrics, and associated terminology for representing streaming media quality of experience across systems, media players, and analytics vendors. It introduces 4 different metric categories, namely aggregate metrics, session metrics, events, and mere player properties. It also includes a couple of events for ad insertion, which are not part of SAND or CMCD. On the other hand, CTA 2066 doesn't specify how metrics are transported. It simply concentrates on the terminology of metrics, so that companies use the same terms when they talk about streaming metrics. And this standard also hopefully improves interoperability across streaming analytics solutions by using the same terminology for metrics and events. So next up, we did the exercise of comparing metrics between CMCD, SAND, and CTA 2066. So in this table, you can see in the first column all the metrics that are specified in the CMCD standard. And we tried to find similar metrics in SAND or CTA 2066. So as you can see here, the most common metrics such as encoded bitrate, buffer length, and buffer starvation can be mapped to SAND metrics. Some of them can also be mapped to CTA 2066 metrics. On the other hand, you can see there are a lot of other metrics that are specified in CMCD which do not have an equivalent metric in SAND or CTA 2066. This is simply because the use cases of CMCD and SAND are different from each other. If you look at metrics such as next object request, next range request, and simply because CMCD is tied to object request, it makes the mapping in this case not possible. But again, this is simply because of different use cases for CMCD and SAND. So to sum up the comparison between CMCD, SAND, and CTA 2066, CMCD metrics are object-based and meant for CDN optimizations. For example, signaling the next request that a player is doing, signaling throughput estimations to the CDN. SAND, on the other hand, is providing raw streaming metrics for time series data and is only partly mappable to CMCD. CTA 2066 provides a common terminology, and most metrics and events can be mapped to SAND. As a result, for our demo, in terms of visualization, we have created separate dashboards for SAND and CMCD. And for the SAND dashboards, we introduced CTA 2066 terminology when there was a direct mapping. So coming to our actual demo, this is an architecture showing how the SAND library uses an adapter to receive raw metric data from a player, in this case -js, then is doing the encapsulation in the SAND library and sends these metrics, whether it's SAND or CMCD, to the metric server. On the metric server itself, we have a database to persist the metrics. And for the UI, we use Grafana, an open source tool, to visualize the metrics in a meaningful way. Now we are having a closer look at the visualization that we are doing with Grafana. And the dashboards that we have set up are usually split up into 3 different categories. We call them the reporting dashboard, which is showing the overall usage and performance of streaming sessions. The error overview dashboard to give an overview and categorization of errors across streaming sessions. And the session details dashboard, which is showing fine-grained metrics of a single session. And as such, these dashboards are supposed to be a video streaming analytics solution for Dash and HLS, where we focus on the debugging part and troubleshooting part by basically collecting very detailed metrics from streaming players to help content providers detect issues, whether it's new devices or software updates, or certain servers, CDNs, licensed servers, which are not responding. In the upcoming slides, we have provided a couple of screenshots from the session details dashboards. This is a screenshot showing the CMCD session details with things like device information, bitrate, buffer length, and a couple of aggregated metrics. Here's a SAN session detail page. As you can see, we're using similar plots, different metrics as discussed before, and another screenshot of a session detail page showing additional SAN metrics. Feel free to have a closer look at our demo. Bye bye.